All right, folks, this is for the people who are gone, so Jake and Kyle, and anybody fifth period, I guess, if they're gone too. This is the start, day 1 of 3 of the semester review for geometry. You guys have a packet, and it has 45 questions in it. The test will also have 45 questions. You have to answer 40 of them, which means you have 5 freebies. If you answer all 45, you get 105% if you get them right, or whatever. So those are just like bonus questions, whatever. You can either leave them blank or answer them, whatever you want to do. This packet you can use on your test, but the test questions are like different numbers and such, and it won't be in the same order. Did I cover everything? Yes. Okay, so we have 45 questions, which means we have to get through 15 questions today. All right, so chapter 0 is all of the algebra stuff. This packet you can use on the test, so you need to make sure you take good notes. Chase. So put your phone away. Here we go. Number 1.
Is there anything we can use on the test, like any notes?
The blue sheet.
The blue sheet, yes. Good. Yes, good. Evaluate this thing. If x is 2, y is -3, z is 4, what do you do?
Just plug in the numbers.
Plug in the numbers. Make sure you use parentheses when you're plugging them in. So -3 plus 2 times 2 all over 10 times 4. We're plugging them in and we're using parentheses as we plug them in. Okay, now what?
Like you just solve. 2 times 2 is 4.
2 times 2 is 4.
-3 is...
I'm going to go 40 on the bottom. So -3 plus 4 is 1 over 40. I want to say 1 over 10, but 1 over 40. There you go. That's it. Easy enough, right? Okay, good. All right, let's go down here and solve for n. How do you solve for n first?
You have to distribute the 1/4.
I don't want to do that.
What?
I mean, you can distribute the 1/4. That's fine.
Subtract the 5.
I'm going to divide the 1/4 off. But dividing by 1/4 is the same thing as multiplying by 4. So I'm going to multiply the 4 to the other side to get rid of the 1/4. Rather than distributing, since 1/4 of 5 doesn't come out nicely, I'm just going to multiply the 4 to the other side. So n plus 5 equals, I think that's like 64 or something. Right? And then you subtract 5. So n is something like 59.
Yep.
That's all. So you can certainly distribute the 1/4 through. That's okay, but it's easier to do it this route when you have it set up like that. Good? Makes sense?
Mm-hmm.
All right, go to the next one. Solve and graph the inequality. So we're solving for r, and we have r's on each side. Let's get the r's together. What do you want to move first?
Subtract the regular r.
Yeah. Subtract the regular r. So subtract r. And can we, that gets rid of him over here, can we subtract the 7 at the same time?
Or why don't we add 8?
No, because that'll get him on the same side as the r. We don't want to do that.
True.
Right? So 2r will be less than -15. Divide by 2. R is less than -7.5. Okay? And if we put that on a number line, we put -7.5 here. And then what?
Open circle.
Open circle, because it's not touching, it's not equal to. And to the left. And this is saying that any number that is less than -7.5, I can plop into here, and it will work, right? That is solving the inequality. When do you flip the sign? Maybe let's put a little star by that.
I do not remember doing like any of this.
When you're multiplying or dividing by
Flip sign when, times, or divide by a negative number. We did not multiply or divide by a negative number, so we do not have to flip the sign. Make sense? All right, these next two are kind of doozies. Substitution and elimination. Do you remember these?
Yeah.
Substitution and elimination.
Okay. The bathroom.
Really? Right now? Okay. Number 4.
Recording this, can you just send it to me?
Sure. I'm going to put this up on Google Classroom, so find it there. Use substitution to solve. Okay, when we're substituting, we have to find something to substitute. So solve for one variable. That's the strategy that you need. You're going to solve for one variable. okay, when we're doing this. Solve for one variable. All right, we have options on number 4. You can solve for this x, this y. Ooh, where'd my writing go? This x or this y. Which one is the easiest one to solve for?
Y,
Which y?
the top one.
The top y. Why is that easiest to solve for?
Doesn't have a
It doesn't have a number for it, right? Okay, so 4x minus y equals 0 if I get y by itself. 4x minus y equals 0. I want to do something kind of weird. Rather than subtracting the 4x over, I'm going to add the y over. Can I do that?
Yeah.
So 4x equals y. Did I solve for y?
Yeah.
Yeah. He's backwards, but that's okay. I solved for y. Now what do I do with that 4x or y equals 4x? Now I plug it into the bottom one because that's what I did not solve for. So I plug it in for y in the bottom. So 6x stays minus 3, but now y is 4x equals 12. Do we see what's going on here?
Yeah.
Do we remember this?
Yep.
Is this okay?
Yep.
All right, so 6x minus 12x equals 12. And then I combine stuff. 6x minus 12x is negative 6x equals 12. And x will end up being like negative 2. Something of that nature, right? Yeah? Okay, now I need to also solve for y though. Where do you want to plug into?
Just plug into the top one. Or the original one. Or like the 4x.
Yeah, this right here is basically the top one solved for, right? When you do substitution, it works out really nicely that you can just take that number and plug it into here. So 4 times negative 2 will give me what the y value is, and that is negative 8. Okay? Final answer? How do you write it? X is negative 2, y is negative 8. How do you write your final answer?
As like 2, negative 2, negative 8.
Negative 2, negative 8. It's an ordered pair. Okay? Now, what happens at that ordered pair? They intersect. These two linear functions will cross each other at negative 2, negative 8. You betcha. Okay? All right, now let's go down and do this one. This one is using elimination. Elimination means that we're going to have to change something so that we can add those equations up and down and get rid of some things, okay? So, would you like to eliminate the x's or eliminate the y's? The y's are very easy, right? This is 5y and 5y, but they don't eliminate with each other right now because if I add them together, that makes 10y. So I want to do something so that they eliminate. What can you do?
Multiply it by negative 1.
Which one?
The bottom one.
It doesn't really matter, right? Multiply the bottom one by a negative 1.
Yeah.
Okay, so negative 1. So I'm going to rewrite the top. The top is 4x plus 5y equals 41. The bottom will be negative 7x minus 5y equals negative 53. And then we're just combining. Okay. So what does 4x and negative 7x make?
Negative 3.
Negative 3x. The 5y's go away equals 41 and negative 53. It's going to be negative 12. Is it 12? Yeah, 12. Okay. So then I divide by negative 3. What's negative 12 divided by negative 3? 4. X equals 4. Okay. Then we plug back in. Where do you want to plug into?
The top.
You can plug it in anywhere you want to, but let's do the top. Sure. 4 times 4 plus 5y equals 41. Okay, am I going too fast? No? Okay, 4 times 4 is 16. Let's subtract that 16 over then. So I have 5y equals, is that 25? I think,
No,
yeah.
Wait.
Yeah, 25 plus 16 is 41. Yep, then divide by 5. And y is 5. So the place where those two are going to intersect is at the point 4, 5. There it is. Okay, good? All right. Number 6, simplify the square root of 80. No decimals. What are they wanting us to do?
Break it down.
Break it down doing like this guy right here, right?
Yeah.
So what goes into 80 that we can take the perfect square root of? If you need to make your list. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, then 25, then 36, then 49, then 64, then 81, then 100, right? You want to choose the biggest number possible. 16, does 16 go into 80? 5 times?
It's gotta be 16.
16 go in 85 times. Now, before I start breaking down, I look at the 5 and I say, okay, will the 5 eventually break down further?
No.
No, because what you could have chosen instead, you might have chosen 4 and 20, but will 20 break down more? Yes. So we want to go with a bigger number then. We want to go with 16 instead of 4, right? 16 and 5. Okay, 16 and 5.
How come you don't have a weird band-aid on your finger?
No, he wasn't giving blood. He was at the Balt meeting.
Oh, you guys went to the blood.
Yep, yep.
Who
Yep.
takes it from their finger?
Yeah.
What?
No, they like.
They poke your finger to see if your hemoglobin's good. You guys want me- I'm going to keep going on the video just in case somebody is going 5th period. So, boys, if you're watching this video, stop here because you just showed up to my class. All right, so we're on number 6. We're writing this down.
Yeah, I think
Whoop.
you guys were doing blood.
16 and 5. Okay, then we start to take square roots. So the square root of 16 and the square root of 5. What's the square root of 16?
4.
4. What's the square root of 5? Square root of 5. It just stays, right? So the square root of 80 is 4 square roots of 5. Okay? Then we have 7 where we have x's and y's and all that good stuff. Okay? So we have 3 pieces in there, a number, an x, and a y, and we're going to break them down and we're just going to do them individually. So the square root of 12 over here, the square root of x to the 5th over here, the square root of y to the 2nd over here. Okay? All right, let's get some practice doing the 12. So 12 is 3 and 4. I'm going to put 4 in the bubble. Okay? And the square root of 4 is 2, and the square root of 3 just stays the square root of 3. Okay, we're going to solve them all out, and then we'll put them all back together. Okay, what about x to the 5th?
If you break that down to.
You always
X
hang
to the
off.
4th and X.
You always hang off 1, right? So this is x to the 4th over here. And then the square root of x to the 4th is x squared. The square root of x just stays the square root of x. Okay? What about y squared?
Broken down into just Y.
Yeah, this one you don't have to like hang 1 off or do anything because it just comes out as y. There's nothing left inside, right? The square root of y squared is just y.
What do you do when you have like 6?
What?
Like x to the 6th or y to the 6th?
Good question. So let's say x to the 6th power. Whoop.
Playing 2 off and
Nope. What's the square root of x to the 6th power? What do you take times itself to get x to the 6th power?
X to the 3rd.
X to the 3rd. So when you have exponents, you're just dividing them in half. Good question. Okay, maybe put a little note up there, right? When you have exponent, I shouldn't have used the number 4 because 4 looks like you're taking the square root of 4 or whatever, yeah, but you're dividing it in half. Okay, so if I take these guys and I put them all back together, what's on the outside yet?
2x squared y.
2x squared y, do you see that? And then 3x on the inside? That's the final answer. Okay, good? All right, that was number 7, so we've got a little ways left to go. Number 8, ready? Name the intersection of planes P and N. This is plane P, this is lane N. Where do they intersect?
AB.
In line AB. So you can either say AB or you could say line AB. However you want to write it, I don't care. You only have to put one of them. But just make sure that we know that it is a line where they're intersecting. Happy with that? Not too bad? Okay. All right, let's go to number 9. Find the length of XZ. So let's look at our parts here. They're saying that from here to here is 8 centimeters, right? Then they're saying from here to here is 2x plus 7. But the entire length is 4x plus 3, right? You see that?
Yep.
So how do we do this?
So 8 plus 2x plus 7 is equal to 4x plus 3.
Yep, this is like that segment addition postulate. So we're taking the 2 smaller pieces, adding together to get the bigger piece, right? So 8 plus 2x plus 7 makes the entire 4x plus 3. Make sense? And then we solve. What can we solve?
Subtract the 2x and subtract the 3.
Yeah. Fair.
I'm gonna combine the 8 and the 7 first. Can I do that?
Yeah.
Okay, so 2x plus 15. I'll make a little smaller step in here. 4x plus 3. Okay, then Luke said subtract the 2x. So that makes him gone over here. And subtract the 3. Makes him gone over here. So 12 is equal to 2x. And x is 6. But we're not done yet. Because they want us to find xz, right? xz. Which one is xz?
Plug in 6 for 4x plus 3.
xz is the whole thing, so 4 times 6 plus 3 is xz.
Are you giving what?
Me? Yeah.
Do you want to give it now?
Can you give me like 10 minutes?
No. No.
Will that work? 10 minutes? No. No, I need to suck some more water down before I give blood, otherwise it's going to be real bad.
You're not even drinking water. You're drinking
I know, I need to go
coffee,
get
you
it.
liar.
Okay? Xz, I'm not drinking coffee, there's water in that. All right, 4 times 6 is 24 plus 3 is 27.
Wait, so what do you have to do? Put 6 back in for 4?
You're finding xz. You see that at the top where it says find xz?
Oh.
So just plug it back in and find xz.
I did it the hard way.
Oh.
I put in the 2x.
Oh, and then you added it to 8. Sure, why not? I mean, you get the same thing. Okay?
I only have like 5 more problems.
All right, 5 more problems. Find the distance. Aha. Okay, distance formula. Write down distance formula. We're going to write the whole formula down. And then, I don't know why I'm so laggy right now. This is crazy. Okay, distance formula. Square root of x2 minus x1 squared plus y2 minus y1 squared. We never use the formula. I mean, we kind of use the formula, but we never do the whole thing. Because we always cheat. You remember that we cheat? Because we do part of it in our head.
Yeah.
All right, how far apart is negative 3 and 4? Those are the x's. 7. How far apart is 1 and 4? 3. It doesn't matter if one of them's negative or positive, whatever, because when you square it, it goes away. So 7 squared is 49 plus 9, which is the square root of 58. What's the square root of 58 as a decimal? You can go ahead and give it to me as a decimal. It is something like 7 point something.
7.62.
7.62. Perfect. Okay. Next, find the midpoint. How do you find the midpoint? Finding the midpoint is like finding the...
The distance and then dividing by...
Right, finding the midpoint is like finding the
Oh, isn't it like 2 times?
average, right? You're finding the average, okay? So if I have 2 coordinates and I'm trying to find the average of them, I'm going to take the x's and add them together and divide by 2, right? I'm averaging the x coordinates, and then I'm averaging the y coordinates. Does that make sense? Averaging the x's, averaging the y's, yeah? Okay, you try that while I go grab water, and then we'll check it. Go. Do you boys want this emailed to you, or do you want me just to put it up in Google Classroom? Because I'm just going to put it on Classroom. Which way is easier? Classroom's fine. Okay. Or if you want to, you can just look at my iPad at the end. Whatever you want to do. Okay? All right. Did you get a midpoint? Okay. So you take negative 2 and you add it to 5 and divide by 2. And you take negative 1 and you add it to a negative 4 and divide by 2. So be careful of your negatives. Negative 2 plus 5 is 3 over 2. And this would be negative 5 over 2. Okay? You can either leave your answer like that, or you can write it as 1.5 comma negative 2.5. I do not care which one you give me. Okay? Either of those will work. Does that make sense? Okay? Good? All right? Good, good, good. All right, here we go. Find the value. We have to read this very carefully. Find the value of x if uv, which is this one, bisects this guy. All right. So what does it mean to bisect something?
Go
Through the middle.
Exactly through the middle. So if this guy is bisecting this line, then it's splitting it exactly in half. So this piece over here is the same as this piece over here. Now be careful, because it does not necessarily mean the other way around, right?
Yeah.
We do not necessarily know that this is split in half, that those two are the same, right? It's saying that it bisects the green one, but it does not necessarily bisect the other one, okay? But we do know that UV, the entire length of UV, which is that up and down one, this guy is 40, okay? So we can't necessarily say 3y minus 1 is equal to 2y plus 6, but we do know that they add up to be 40. Make sense? Okay, so let's solve for x and y. All right, so let's write some things we know. We know that the green ones match, right? So let's go over here. 3x minus 2 is equal to 3y plus 1. Right? Just wait. I'm going to write that out, okay? So we know that these two match, right? Those two are the same as each other, right? Okay? But the problem is, Jake said we can't solve x and y at the same time, right? Like, why wouldn't you do something else first? So I'm going to write that out because we're going to come back to that. But now what?
3y minus 1.
3y minus 1.
2y plus 6 is equal to 40. You just solve.
Yep. So we don't know that they're equal to each other, but we do know that they add up to be 40. Okay, so we're going to solve that thing and then plug back the y in. Okay, so let's combine stuff. 3y and 2y, add it together. Make 5y. Negative 1 and 6 go together. And that's plus 5 equals 40. Okay, let's subtract the 5, subtract the 5. So 5y equals 35. 35?
What?
What? Subtract 5,
Yeah.
divide by 5.
Okay.
Did you think it was 45 too?
I had the wrong, I had -6.
Yeah.
That makes no sense.
Is it negative 6?
No.
No.
Okay. I might have written 7 down wrong. So y is 7. Now, we can go back to the original guy over here. I'll zoom out. And we're going to put 7 in for y over here. Okay. All right. 3 times 7 is 21 plus 1 is 22.
Subtract 2.
No, add the 2. Add the 2. Plus 2 plus 2. So 3x equals 24. And x is going to be 8. Beautiful. Okay, we solved for x and y. Very nice. All right, next, find the value of x and y for this diagram. Let's figure out some stuff that we know. What do we know?
That one angle 72.
This angle's 72? How do you know how this angle's 72?
Because it says so.
No, the other angle. Or we know that
Well, I mean, it is
10x
72
minus
because the vertical
24
angles.
Oh,
is equal to 90.
That's the angle I was.
okay, 10x minus 24 is equal to 90, because that's a box over there. So we're going to say that this guy equals 90. Okay, let's figure out how to solve for this guy. What's this guy going to be equal to?
Huh?
Which one?
72.
Which one's 40 degrees?
This one right, oh, 40 degrees is this angle.
Oh, okay.
What is 8y minus 16 equivalent to?
72.
Why?
The vertical angle.
They're vertical angles, right? They're across from each other. So this is 72 as well. Okay, so we got them all ready to go. Let's solve. So 10x minus 24 equals 90. And 8y minus 16 equals 72. And we shall solve. All right, I'm going to add the 24 over.
You get 114.
10x equals 114. Divide by 10. Just move the decimal. X is 11.4. Not a nice number, but that's okay. This was actually one of the test questions that you guys had on your test. I don't know if you remember this problem, but anyway. Okay, add 16. Add 16. 8y is equal to 88. Divide by 8. Y is 11. Beautiful. Okay, same diagram. Now we're finding the measure of angle 2.
So we have 90 RA in there, right?
Where?
Okay,
Angle
but
2.
for angle
Oh, but we don't know this angle right here. If you're looking at that, he's looking at this triangle, right? To find angle 2. We don't know what this angle is over here, so we can't use that.
Just
Well,
take
we use
72
72 plus 40.
Okay. So they're looking at this being a straight line right here, right? And this guy's 72, and this guy's 40. They all have to add up to be 180, so this will be the rest of that.
Yeah.
Does that make sense?
So one.
Yeah.
108.
112. What? 72 plus 40? Is that 112?
Yeah.
Okay. You subtract that from 180, and it is 68 degrees. Is that right or not? 68 degrees is angle 2. Okay. All right. Good. Last one. Yeah, and then we're to the end of the chapter, so this is a very good stopping point. Name polygon ABCDEF by its sides, then classify it as convex, concave, or regular or irregular. So, do you remember when we said that he has a first name, middle name, last name?
Yeah.
Okay. So his first name
Concave.
is convex, concave. So this is the first name. The middle name is no. First name.
Yeah, the first name.
First name is irregular, regular, irregular. So this is the first name.
It's regular.
Okay, and it is regular. How do you know it's regular?
Because everything is
Okay, all of the sides and all of the angles. It has to be sides and angles to be regular. So that's the first name. The middle name is either convex or concave. Convex. Concave caves in. So it is a regular convex.
Hexagon.
And there are 6 sides, he says. Hexagon. That is his last name. Name the polygon by its sides is the last name. So regular, convex, hexagon. Do you guys know your shapes? Like triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon. Hendecagon, I won't give you that. And dodecagon is 12. Okay, good?
Can I see your
Happy
notes?
with that? All right, I'm gonna pause the video.
5 and 6.